alpha decay, and what will happen? It will attain the stability, that one. What about the energy released here? What about the energy released? So the energy released here, so I'll go for like this: mass of parent minus mass of even if you want, you can take the electrons, but I think the what is the mass of electrons? So we can, or I'll do one thing, one problem, I'll show it. There's the mass of parent. I think in books they are not shown mass of daughter. So 2 electrons c square. This is c square plus what it should be mass of alpha helium minus 2e 2me. This was the overall sequence, that one. So when you solve this, what you get? Mx my minus mass of helium into c square. So usually the electrons, what happen, we don't bother, because when you compare the mass of electrons with the nucleus, will be negligible, no? Only in beta decay, in one of the beta decay process, the mass of electron will come into picture. In most of the nuclear reactions, the mass of electrons will not come into existence. So this is the basic thing, that one. Okay, now look at this particular thing, the daughter nucleus. What happened? The charge decreased by 2 and the mass number decreases by 4. So the daughter nucleus, what happened? Z minus 2, I should put it. What about the helium? What the helium? It's the alpha helium nucleus, no? So minus 2 Me is what I should write, not plus 2 Me. It's not a helium atom. What we are getting? Helium atom minus mass of electrons will become what happened? Helium nucleus. Able to get this? So what is this? This everything is, this is what? Mass of helium atom minus mass of electrons will give the alpha particle, mass of alpha particle. So that's what we have substituted. So in our books, if you see, no, they have just wrote only this, directly this equation. I think justified. No, sir, I'll consider mass of electrons, solve it and do it. No, it will be very negligible. Eighth decimal place will have some small change, or 10th decimal place. It doesn't matter. Means in the final answer, if you consider mass of electron. So that's why the most of the books open, they didn't bother. Even SC or Ma, you take Cengage book. So in advance, sometimes they may trouble you with in terms of this. Like this is what you have to write. So I suggest you don't think like this. Directly come for this. That is substitute that and get the answer. Now, what about the alpha particles? Means there's a, let's get into some part of physics here. From where that alpha particle will come? From the nucleus. From the inside the nucleus, that alpha particle will come. If there's a daughter parent nucleus X, then initially let it be a test. It will emit alpha particle. Then it will become daughter. Then it will have kinetic energy Ky. And the alpha particle emitted. So this alpha particle emerges from nucleus. From the nucleus. So then initially it was a test and finally they are moving. No? So if you apply conservation momentum, as you can go for 0 is equal to root of 2ml k alpha minus 2my ky. And what is q is equal to mx minus my minus m alpha into c square. And this q, directly I'm writing it for this particular thing. And what is q should be equal to ky plus k alpha. I think I'll give mass of the daughter, parent, and alpha particle. I'll substitute. Then I'll get the q. Then ky, k alpha, two unknowns. and ky and k alpha, here two unknown. Solving these two, what happen, will get the required answer. Like this, any questions will be asked here. So now what is the recoil speed of the nucleus y? I think when you know ky, you can predict. Because since we'll be having information only in terms of kinetic energy, I'm writing the equation in terms of this. The most of the numericals what we do will be having information in terms of kinetic energy of the particles only, not like a speed. We can measure the kinetic energy, that one. So based on that, I'm writing these equations. So I think you have to practice. There's no way even I to feel. Suppose if I'm solving any question, no, up to 4 decimal without calculator, really very difficult. With calculator you can manage, but in exams you're not proposed to use, no, you're not certain to use calculator. So I think better now only without calculator you practice it, so that in exam you'll get habituated. We'll take one problem. No, what about I think this is one item we discussed, no? So usually what happen? We'll go for the sample. Sample means in a there's an active alpha decay sample. Means 1 kg. Let me put it this one. All these are X atoms, X nucleus. All they are active. They want to undergo decay, they'll undergo alpha decay. Then what do we get? We get it will form what about the alpha particles which are emitted from this sample? I'll do measure. Will all alpha particles must have same energy, or different alpha particles different energy? I'll take active alpha decay sample, then let it undergo alpha decay, then we'll get there's the parent, there's a daughter. Then we'll get alpha particles, no? Around 9 alpha particles. What is the kinetic energy of all those 9 alpha particles? Must be same, because here the kinetic energy carried by alpha particle will determined by the ratio of masses, no? M alpha and My. And for all parent and daughter nuclei, what happens? They will have same mass. So what is the kinetic energy of all alpha particles? Must be same. Suppose say here only I'll show it. Suppose this alpha particle is having ky. What about k alpha? K alpha will be somewhere like this. This is emitted like this. Different directions will show it. There's no rule that along x-axis only. What about this alpha particle? This alpha particle here, for this k alpha. For this it will be I have to show two more, no? Yeah. No, this alpha particle for this will be k alpha, for this it will be. What is the kinetic energy of all these alpha particles? Must be same. And there's no rule that all the alpha particles must be emitted in same direction. Need not, no? Oh. I'll get back the screen. Oh, I think lost it. Okay, I'll redraw it once again. This is X daughter and it's parent, and these are Y means daughter. All they are at rest. Parents at rest. These are the daughter forms, so we'll get alpha particle 1 here. They may ask you some diagrams like this, you be careful for everyone. Okay, this is no comfort, so this will be KY. Actually, we have to show momentum, so I'm just showing it. What is the kinetic energy of all these alpha particles will be same. So shall we put monoenergetic, inactive, alpha decay sample, the kinetic energy of all emitted alpha, the kinetic energy of all emitted alpha particles will be same. So if you go for the graph, so if this is the kinetic energy of alpha particle, this is the number of alpha particles. What I should do? Almost, I'll put a peak like this. Finish over. All will have same kinetic energy. Why do say that small difference is due to quantum mechanics? We can't explain using classical mechanics. Just leave it, because the daughter nucleus formed may not be exactly the ground state, maybe in excited state. So to come to the ground state, it can happen. So it need not be one vertical line. You can put a peak like this, somewhere in this region. This is the number of alpha particles. So all alpha particles shall be put almost like a monoenergetic. Enough. That is, all alpha particles will be same. The kinetic energy of all alpha particles will be same. This is the basic idea of the alpha particle. So now what happens is, like in some of the reactions, means some of the nuclei, it happens that there is a parent, it undergoes decay. Where it will be in an excited state. Excited state will put star mark plus alpha particle. Then energy will be released here. So what again this will do? To come to the ground state, this particular daughter nuclei, it has to give out a gamma photon. So when after alpha decay, if the daughter nuclei which is formed, if it is in excited state, to come to the ground state, what happen? It should give out a gamma photon, that one. So it's almost like excitation, how we had in atomic structure. Similar way, what happen? Even for the daughter nucleus, newly formed daughter nucleus, within excitation to come to ground state, so it has to give out a photon. This photon from where emerges from nucleus. Is it all? We don't know, sir, which particular daughter nucleus formed will emit gamma photon, which will not. I think the physics, what we know, we cannot answer because all are active alpha. And in that, what means some 30% will emit, will be in excited state when newly formed daughter nucleus, 30% will be in excited state. Remaining 70% will be in the ground state. So why do it happen? I think we have to enter into quantum mechanics. There's no answer from our side. Just we know information and we have to just accept it. What about the energy equations? How to manage? The energy equations here will be mx minus my minus m alpha into c square. Okay, fine. This is then this energy who will share? The energy will be shared by daughter nucleus alpha particle plus also the energy of the photon. What is the energy of photon? Sc gamma. In that case, what do you expect now? Again, the same equations. Huh? See, this alpha particle will be emitted. Now, what all this Q what happened? That Q what happened, you should not write only equal to ky plus k alpha. That Q what happened, you have to introduce for this. Some energy what happened will be taken by the gamma photon. Means the moment daughter formed, again you'll get de-excitation. Then a gamma photon will come. So the calculation of Q what happened, you have to bring this one here. So definitely what happened, the share, what all that energy is there will not be shared by only the daughter kinetic energy of the daughter nucleus and alpha particle. A part will be converted into the photon, gamma photon in this case here. So what are the probability? That's what it all depends upon the active alpha decay sample. In that 30%, 40%, 50%, some will undergo 80%. If suppose a 100 parent nucleus X are there, in that what happens, around 80 daughter nuclear form will be in excited state and we get 80 gamma photons. Remaining 20 is this will not be there. Why it happens? We have an explanation, but we have to go to quantum level. So at our level, I think they may ask you just numerical, just manage, finish over. Agree this. So this is about the theoretical information. We'll take one numerical. SC, sorry, this should be lambda. Or if you want E gamma, I'll write it. What is lambda gamma? Wavelength of gamma photon. In hydrogen, what happened? We had energy difference so much it was in only kilo electron volt. No, in the nucleus, the difference in energies what happened will be of order a few tens of mega electron volt. Definitely, this gamma is not something negligible. Lambda gamma means this energy of gamma photon will be very high.